So this problem is 2019 AMC 10A, problem 13. Let triangle ABC be an isosceles triangle with BC equals AC and angle ACB equals 40 degrees. Construct the circle of diameter BC and let D and E be the other intersection points of the circle with the sides AC and AB, respectively. Let F be the intersection of the diagonals of the quadrilateral BCDE. What is the degree measure of angle BFC? So we have 5 options A, B, C, D, E. And here the first step is to visualize our problem, because as you can see there are many conditions and it's really hard to visualize if we don't draw a graph on the paper. So here I'm going to draw one on my screen. So I have my circle and my triangle here is going to be C, B, and A. So CB is the diameter of my circle and CB is equal to AC. I also have BCA is 40 degrees. It also says here that let D and E be the other intersection points of the circle with the sides AC and AB. So this point here is going to be D. This point here is going to be E. So where's F? So it says let F be the intersection of the diagonals of the quadrilateral BCDE. So the intersection of B, C, D, E. So this is my quadrilateral, and where are the diagonals? My diagonals are CE. So let me just draw that, CE and BD. So these two are my diagonals. So my point F is going to be here. So that's my point F. So I want to figure out BFC, which is this angle over here. So that doesn't look too hard, but it looks a bit confusing. What are we going to do? So this problem is basically just angle tracing. So we know that BC is a diameter. And for any diameter, so if I had a circle here, for any diameter, so let's say that's my diameter. So for any diameter, I have, so if I had the vertex of my angle to be on the circle and the two sides, the two rays of my angle to pass through B and C, my diameter points, then any angle like this would be 90 degrees. So even any angle like that, that's also 90 degrees. So that's also 90 degrees. And also any other angles, like this one is also 90. That is also 90. So this is an important property you have to know for it to do problems related to circles. So using that information, we know that angle BDC is 90. And angle BEC is also 90. So that's really, really useful information. So we know angle BDC, we know angle BCD, so we can figure out angle angle CBD. That's just 50 degrees. So 180 minus 40 minus 90, so that's 50 degrees. And we also know that here angle CBA is equal to angle CAB, which is equal to, so that's equal to 70 degrees because CB is equal to CA. So the base angles are equal. And we have the vertex angle to be 40 degrees. So the base angles are 70. So we have angle DBA is 20 degrees. So this angle here is 20 degrees. So I won't write that there. So there's no space. So we know that. So we know from this piece of information, we also have 90 degrees over here. And we have 20 degrees over here. So we can figure out angle BFE. So angle BFE is going to be 90 degrees minus 20 degrees, which is 70 degrees. So that's angle BFE. That's 70 degrees. We know that angle BFC, the angle we're desiring, is 180 degrees minus 70 degrees. So that gives us 110 degrees. So So our answer is just 110 degrees. The important part here is to realize that we can use the fact that BC is a diameter to figure out a lot of right angles, and then we can use right angles to do some angle chasing. So thanks for watching.